Hello, ladies and gentlemen, and welcome to the last chapter of Algebra 2. So this chapter is going to focus on how to graph sine and cosine functions. Now, sine and cosine functions are very useful in real life. We look at them when we look at earthquakes. We look at them when we look at electronics, and EKGs and everything. There's a lot of usefulness to sine and cosine functions in this world. Now, yesterday we did the spaghetti lab with one another, and you found the sine function and the cosine function look something like this. It kind of goes in what, and you could almost consider a wave pattern, like this, right? This one kind of went like this, the cosine function. Okay, so they have a little different of a look to them, so we'll look at both sine and cosine just to see the differences and how they're graphed a little differently. But we have a lot of vocab today, a lot of vocab. You're going to want to copy some of this vocab down. So a cycle of a periodic or repeating function is a portion of the graph of the function from one point on the graph to the point at which the graph starts repeating itself. So that's the cycle. So basically what that means is wherever the graph starts actually repeating itself, because these are going to repeat themselves over a certain period. Now, a period is a trigonometric function, is the number of degrees, or if we're talking radians, taken to complete one cycle. And then the distance to which a sine or cosine graph rises or falls below its axis is the amplitude. Let's take a look at an actual picture of this. So here's my sine function in particular. I have an amplitude right here. Notice it's how high the graph is from the x-axis. This amplitude here is the same as this amplitude here. We're going to mark those in with a particular color when we graph. That way we know where we need to hit for the highs and the lows. Now, a period, if you see that it's gone from here to here, notice how once I get back, this part would start this part again, right? It's going to keep going round and up and down and up and down. That is one period. A period is enough to complete one up and down cycle, pretty much, okay? The cycle is going up and down, up and down, up and down. So let's first take a look at sine. So sine has some pretty interesting ideas. Original sine has an amplitude of 1. Okay? So it's going to go up and down on 1 and -1. Okay? Its period, aka how long does it take to repeat itself, is 2 pi radians, aka 360 degrees. And you saw that when you did your spaghetti lab. The increment, or how far much you're going to do each time, is pi over 2. Which kind of makes sense, right? If I go pi over 2, pi, 3 pi over 2, 2 pi, you need to break it up into fourths. That's pretty much what we're doing. Now, what makes sine different than cosine? Sine is going to start at 0, 0. It's going to run through the origin. Okay? Or wherever your origin may be once we start doing some vertical shift. And then it's going to climb up and then go down. And up and then go down. It's going to cross the x-axis twice. Once at pi and once at 2 pi. And then we're going to have a max of pi over 2 and a min at 3 pi over 2. Now, notice how on this side, it's the same as what it would be on this side. So this is one complete area too. So just kind of keep in mind where certain things are. The biggest thing about sine that I would make sure you know is that it starts at 0, 0. And it has a period of 2 pi. Just because the starting at 0, 0 is going to break it from the cosine that you're going to see in a moment here. So let's take a look at cosine. Cosine still has an amplitude of 1 because we haven't changed it yet. Its period is also 2 pi, or 360 degrees, which makes my increment pi over 2. Now, notice how cosine's a little different. It starts up in the top, so it doesn't cross through the origin at all. It will always start at the top. So cosine is going to start at the top. Sine is going to go through 0, 0. Now, cosine is going to cross through pi over 2 and 3 pi over 2. The opposite of sine. Sine crossed through pi and 2 pi. And he's going to have a max at 0 and a min at pi, which is the opposite of sine. Now, like I said, please make sure that you recognize a cosine graph starts at the top. It doesn't go through 0, 0. It starts at the maximum, or your amplitude, the top right beside your amplitude. Now, how are you going to find this if they change this around? Because your amplitude will change, your period might change, and your increment may change as well. To find your amplitude, you're going to do the absolute value of A. AKA, if it's 3, your amplitude is 3. So if this A right here is a 3, your amplitude would have been 3. If it's a negative 3, it's still 3. Your amplitude cannot be negative. To find your period, what you're going to do, see this B, it's going to be right beside X, inside the sign. You're going to go 2 pi, 360 degrees, divided by whatever B may be. Sometimes it can be a fraction, which is going to be gross, but that's not too bad. You can divide that on your calculator. To find your increment, you're going to do whatever your period was, divided by 4. So you're going to cut it into fourths. Another way to think of this, 1/4 of the period. So if I have a period of 2 pi, I would have a pi over 2 increment. That way it splits it nice and easily for us to be able to graph. So let's actually do something with this. Very first thing, we can figure out our amplitude, our period, and our increment. We'll figure out domain and range when we're done graphing. So my amplitude is my A, which is right here. So my amplitude is 2. My period, I'm going to do 2 pi divided by my B. Now notice how I don't have a B. Let's just assume it's 1, okay? Because if there's nothing in there, it's got to be a 1. So 2 pi divided by 1, that's 2 pi. My increment is my period divided by 4. So 2 pi divided by 4 cancels off. I'll get pi over 2, right? 1 pi over 2. Okay, now here is a word of the wise. You are going to want to have an extra color to be able to graph your amplitude in. So your regular graph can be in your pencil, but have a color for your amplitude. So my graph is going to be in black. Right here, I'm going to graph something like this. It could be really long, okay? My amplitude, I got to mark it off. It is an amplitude of 2. So on my y-axis here, I'm going to mark to 2 and to -2. Now, to make sure I don't mess up, I'm going to take my blue pen. So that way, every single assignment I do, every single video I do, my amplitude will be blue. That makes it make sure that I don't cross it. So here's my amplitude. I'm going to draw a blue line through there. So that way I know that's where I have to touch, and that's where I cannot cross. Okay? So I have some my amplitude lines driven out because I'm going up and down 2. Now, we need to start labeling our period. So I'm going to change back to my pencil or whatever color you're using for your regular graph. My increment is how I'm going to actually label my graph. So right here, I would have pi over 2. Right here, I would have 2 pi over 2, right? Which is the same as pi. All right. 3 pi over 2. I'd get 4 pi over 2. 4 pi over 2 is the same as 2 pi. I would have 5 pi over 2, 6 pi over 2, 3 pi, and you might start seeing the pattern here. So I'll go 7 pi over 2, and whoop, I got a little carried away. Not 8 pi, but 4 pi. There we go. Now, did sine, this is when you got to remember back, did sine start at the top or go through 0, 0? It went through 0, 0. So we're going to start here and go up. Now, before I hit pi over 2, right here, I need to get to this top, right there for pi over 2. So right about there. Notice how I'm not covering, going over my amplitude. That tells me that's how high my graph needs to go. Now, slowly and surely, I'm going to make my descent, and I need to cross here at pi. So let's drop down until I hit to pi. Crossed over right there. Go down. Now, at 3 pi over 2, I now need to hit the bottom here. So I'm going to start going down here. Hit the bottom at 3 pi over 2, bounce back up, and I'm going to continue this until I am done with my graph. There we go. Put some arrows on the end of here so that way I know that I have graphed it, and it's going to continue that way forever and ever and ever. Now, notice how I am never not going to hit an x value, right? So my domain values are going to be all reals all the time. That covers for cosine and sine. Your range, though, your range is going to be a little weird. Notice how I'm bouncing between -2 and 2. We need to say I am going to be between -2 and 2. So this is how it's going to look. It's going to say -2 is less than or equal to y, aka y is greater than or equal to -2. But y is also less than 2. And that is how I graph my sine function. Let's take a look at another one. So I need to find my amplitude, my period, my increment, and then domain and range we'll cover at the end. So amplitude, notice how I don't have an a in front, so I'm just going to call it a 1. My period, though, this one's going to be a little different. So 2 pi divided by b. My b is 1/2. Oh, goodness. How do I graph 1/2? So 2 pi divided by 1/2. If you type that in your calculator, just go 2 divided by 1/2. You will get 4. So that pi is just going to come along. It's going to be 4 pi for my period. So basically, I'm going to double my period. Increment is I'm going to go 4 pi divided by 4. So my increment is going to be in pi's. So let's go ahead and start graphing our graph here. There we go. Okay. Let's put in my amplitudes. Right here is a -1. Right here is going to be my +1. Just like last time, pick my blue to draw in my amplitude here. That way I know what not to cross. Whoa! There we go. Alright, now start labeling my increments here. My increment was pi, so every time I make a mark, it's going to be a pi. So that one's pi, this one would be 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi, and 8 pi. Notice how I'm doing 2 full periods. On your assignments, you will be asked to always do 2 full periods of the graph. That way, you get a nice graph that looks very nice. Let's just put it that way. So now let's graph my graph. It's a sine again, so it's going to go through 0, 0. So it's going to go through here, and it's going to bounce at pi, hit the 1, go back down, cross over at 2 pi, bounce at 3 pi, cross at 4 pi, bounce at 5 pi, cross at 6 pi, bounce at 7 pi, and cross at 8 pi. Okay, now notice mine's not as perfect as it probably should look just because my increments are not accurate. But nevertheless, my domain is of course all reals again. And I'm bouncing between -1 and 1. So my range is going to be -1 is less than or equal to y, which is less than or equal to 1. Let's try one more. Notice this one's cosine. We're not going to treat it much different, except its graph's going to look a tiny bit different. Don't have amplitude in front, so my amplitude's going to be a 1. My period, this is going to be a little strange. 2 pi divided by my b, which is pi. So 2 pi divided by pi. Pi's cancel. My period is just 2, which is amazing. Don't have to worry about counting in pi's. So my increment then is going to be my period divided by 4, aka 1/2. Your domain, you can probably write that down already. It's all reals. Okay, let's make a graph here. Put in my amplitude, 1, -1. And again, just like last time, take my blue, because that's my amplitude color, and draw across. That way I know I'm not going to cross that line. Can't cross it, can't touch it. So then, let's start making my increments. My increments are in halves. So I'm going to have 1/2, 1, 1.5, 2, 2.5, 3, 3.5, 4. Notice I went 2 full periods. Always make sure you count 2 full periods, okay? So now I can graph my graph. Now, remember, cosine can't go through 0, 0. It starts at the tip top. So on this one, it's going to start here at 1, and it's going to start going downwards right away. So it's going to go down through 1/2, bounce at 1, go through 1 and 1/2, bounce at 2, 2.5 is going to go straight through, bounce at 3, go through 3.5, and bounce at 4. Notice at 2, it's going down again, just like we started. And at 4, it would start going down again. They should always mirror each other. You should be able to take a piece from 0 to 2 and move it from 2 to 4, and it should look exactly the same. That's what's so cool about trig functions and why they're so easy to graph. Now my range, if you remember, it bounced between -1 and 1. So it's going to look something like that. And that's the end of this video. Thanks for watching. This is Miss Marsh, signing off.